Hi everyone, welcome again to my YouTube channel Fitness Spirit Computer Geek. In the last lecture, we have seen some fundamental concept of pointers where I've shown you what is a pointer and why we are studying the pointers and what is its usage in our system, in C, specifically in C programming. So in this lecture, I have told you that in the last lecture I have told you some of the fundamental concept of pointers via some diagrams and some illustration. We have just gone through the basic of pointer where I haven't given you some formal definition or formal information about pointers. Now in this lecture, I will be giving you some basic fundamentals of pointers in some formal terms. Last lecture was all about informal terms. We have just I've just given you some informals about what is a pointer and what is the uses of pointers. Now in this lecture we will be discussing about some few points on pointers and some formal points of pointer. Okay, so without wasting any time, let's begin. So here we go, pointers. The last lecture you have seen about this, actually if you remember this, we have seen what is pointers. Actually I've given you some addressing, how whatever you write in codes have to be converted in binary actually, and then it is stored in our memory 101010 format and in addressing format. So this address, I have also told you that our computer always already using the pointers by itself by by taking any data stored in the binary position, which is actually a addressing position with which we have discussed in the last lecture. So now in this lecture, let me just now here we go for guys. If you remember this term point, this is the basics of pointer. If you just can remember this, you will the basic concept of pointer will be always clear to you. Okay guys, so now let me just see some pointers. So our first point is a pointer is a variable that contains the address of a variable. This point, no need of explanation, you already know this point guys. So if you remember, so pointer is a variable, so it is actually a variable. If you remember my illustration I have given in the last lecture, this is suppose the one dimensional array, the snapshot of addressing. So if you remember in my last lecture, I have already told you that if we will declare pointers, so if you remember the declaration, we have used asterisk symbol to distinguish it from normal variable, as it is a variable which is a address of some variable. So it will be p. So and suppose we declare one variable here int c, and if you reference them as ampersand, it will store the address of c. So the point of this the guest of this point is p is a pointer. Okay, so it is also a variable. Okay, it will have will be located in the same address of the memory of the computer, and it will point to some variable, non-pointer variable, which have some value, and using this variable now we can access this pointer. So guest of the pointer is a variable that contains the address of the variable. Okay, of course. So suppose this will have some address like x00. So x00 will be stored in this. So it is a variable that stores some variables, and to distinguish it using, so this pointer can be distinguished using this asterisk symbol. Remember this part, and this is addressing operator. So you can in naive term you can understand that this is used to access the address of some variable, and this is used to address the contain of some variable which is being pointed to. So and one more thing about this thing is, which I will show you later, that this int pointer is not the size of pointer. Okay, don't think it as the size of pointer. Some of you might be confused, might be remember from earlier lectures that if you declare some primitive type data type like a, so int will have a data type of p. Pointer is not having a data type of int. Actually it will have data type of only this variable, which is its string pointer. So later I will told you that in pointer arithmetics why we are using int here. So if you use here float p asterisk p equal to address of c, it is also correct logically. Okay, so some compiler will give warning, but it's correct, you can define it, no doubt, because pointer have data type of addressing, means which architecture your your computer is following. So bit 32 or 64, according to this your size of pointer will be declared, not which we here declared here. Okay, hope this point is clear, make it clear here guys. Okay, that the size of pointer is only depend on architecture, not on the data type that we are using. It is just used to point to the address of the data type which we are being pointing, which will help in pointers arithmetic only. So int asterisk p mean p is a pointer to an integer. So what is this mean? P is a pointer to an integer. Okay, hope it is clear. This mean, and this is the pointer to floating point. Pointer to an integer means it is a pointers p, which is actually the normal type of pointer is depend on architecture that which addressing mode is found. But if it specifically declare int here, means it is going to store the data of a variable which is integer type. That is only means which is helpful in pointers arithmetic. So last time I'm showing you this, that was not the case here. Okay, so print p equal to c, address of c and int c. So what I mean with this actually, so this data type for asterisk p is used to not to say the size of pointer, but size of a pointer, but to use in pointers arithmetic. Means suppose we need to increment the variable p, because now p is pointing to variable c, so you can use p as a replacement of c. Okay, so suppose we increment the pointer p, so pointer arithmetic is very essential. So if you increment pointer c, so how many element it will be increment, means how the pointer will, you already know that, and then addresses is given in like this format, usually always in bits bytes. Means one address is depend on the architecture of the computer. Suppose it use addressing mode of 32, suppose it is using the addressing mode of 8 bits. So just for sake of simplicity, addressing will be done in 8 bit only, 1 2 3 4 5 6 7 8. Okay, so it's depend on system. So suppose 8 bit architecture is being used, 8 bit of one slot addressing slot is of 8 bit size. So whenever we declare a data type, suppose char data type, according to system it will cover 1 byte or 2 bytes. So suppose it cover 1 byte, means 1 byte is equal to 8 bits, so this part will be for dedicated to char part. But if you declare int here, and the int data type also varies, 2 bytes or 4 bytes according to the architecture you are using. Suppose my architecture allowed 2 bits, so means 8 bit, this 8 bit, and let me show you in different color, this 8 bits and this 8 bits combined, so this will 16 bit, and 16 bit is equal to 2 byte. So int will cover these 2 points. So if you increment the pointer is actually pointing to address of something. So if you increment the pointer and does not specify the address, it will increment individually. So it will point to this point, but it is not the case here, because these 2 byte combinedly is integer part, so it will give us wrong result. So to compensate that, you have to specify the if the variable is int type, then you to also specify the start p type of int pointed to an integer, because it will be pointed to integer, means a variable is pointing to an integer variable. So int p means that. So if you write float here, then it will increment accordingly. So if 4 is 4 bytes, so it will be increment like this, but it's not the case. The incrementing should be value +1 should means we reach here. Okay, so hope you are understanding this. This is the case here. So for pointer arithmetic, this is has to be specified according to the address pointer, according to the variable which the pointer is pointing to. So if p plus 1 is means p equal to, p is addressing 1 now, so p equal to p into 2 now, address of 2 plus 1 means plus 1 means, so plus 1 meaning is p plus 2 into 1. So now size of the address will be added to this. So now suppose the address of this is 100, so it will be 102, 101, and this is 102. So it will point to 102 to the next addressing. So this is the next integer type. Okay, where is stored? Assume that. So in this way the pointer arithmetic will. So what is the basic point here? That p, if p is incremented, then p plus size into the value which are incrementing. So this will be the formula here. So for this size to be specific, to specify this size, okay, so specify this size, we have to define the data type. Suppose it is integer type, so int float, according to this it will do the calculation. Okay, so hope you are getting this point, guys. So moving on, let me see the let me show you guys the next point. The size of the pointer depend on the architecture. However, in 32-bit architecture, size of pointer 2 bytes. So what I was talking is written here. You can see that. So I have already told you that size of pointer is depend on architecture, not on the data type. Don't think like that. If you declare char here, char, then pointer size will be of char p. Forget about the traditional primitive data type where we used to declare a variable type, which is the type of that variable. No, it's not. It's not the type of pointer. It's just is a pointer it's this mean that it's pointed to a character, means this is pointing to a variable which is of character type. Okay, this pointer variable p is pointing to a variable which is of char type. Okay, remember this. So it will actually 2 byte according to your system, 32 byte structure. Size of pointer, size of variable p will, if you type, then it will give according size of. So if you use size of operator in C plus plus C, then size of p, it will return to the address of the variable pointer variable p, which depend on the data structure which is following 32 bits or 64 bit. Okay, it's depend on that. Okay, hope you're getting this point, guys. So now moving on. Now let me give you the next point. To asset address of a variable to a pointer, we use a unary operator ampersand that return the address of that variable. So I've already told you this from the last lecture also. So if this point self-explanatory point. So to assess the address of a variable, so how we gonna assess the address of a variable? So suppose that we have variable a, int a, and char b, something like that. So how we gonna assess the address of this variable? These are being declared by operating system, and space is being allocated according to the paging or the memory management by used by computer system our operating system. Memory has been allocated to these variables according to operating system. So how we gonna assess the variable? How we gonna assess the address of those variable? So operating system by C language provide this with a sign. Remember this sign, ampersand sign. So this is used to assess the address of any variable. So if we just use a and store it some pointer variable, it will just give and display C. So if we see out, not see out, printf percentage u for unsigned integer, which will cover all the addressing mode. Okay, so and just print p here. So it will actually give you the address of this variable. Okay, so there's so much power. You can imagine power of pointers here. So unary operator ampersand, remember this. So if you declare it, means if a variable has some address of x10, so it will just print x10 here. Okay, so hope this is clear to you guys. Now what's the ampersand operator do? It just used to assess the address of any variable. Okay, so now moving on. So our next point is, for example, ampersand and give the address of the variable x. So if you what I explained there though, so if you use ampersand sign before the prefix of the variable, it will use to assess the address of that variable. Okay, so now so declare pointer where a asterisk is used, there must be a asterisk. So asterisk variable, which you already know that. Let me just give you the brief idea. So asterisk variable is used to declare the pointer variable. So it means a star is a pointer. It's just a mnemonic. A is pointing to a pointer variable, pointing to a variable of type integer. So ampersand is used to declare the address of. So one more thing you can see, I will told so you the help code that p star p may if a is given, a will store the value of c. Suppose the variable c is declared as normal integer variable. Okay, so if you use, so it will gives the value at address of c. Okay, value at address of c. And if you just printf p here, means a here, so it will give address of the variable a. Or if you just printf star a, it will give the value. So what does this mean? This mean that, so this mean that print the value at a. So a contain what? A contain the address of c. So this means the address of c is some address and that value. So it is also used to get the value of any variable which we want. So this is the usage of asterisk here. Okay, so you will understand more about this when I will give you some examples. Okay, so hope this is clear to you guys. So now moving on. So in the from the last lecture, I have just showing you that pointer and addresses. I just begin the lecture of pointer using the concept of addresses. So you already know this part. I'm just repeating here. Okay, what does this mean? So let me just make it clear one more time. So this is a big chunk of memory. Suppose this chunk of memory, and the chunk of memory will be allocated to the variables according to the code you have written here. Okay, hope this is clear. Now suppose that code I write here, and the code contain integer variable a, floating variable B, character variable C. Suppose we have three variable here. Okay. So according to the base addressing mode and the architecture you are using, it will allocate it. So int A is 2 byte in 64-bit architecture. So it will have these 2 byte combinedly will set to as integer. Okay. These 2 bit combinedly as into A. Okay. What is it of this relative? Float B means it will cover 4 bytes. Okay. So 4 bytes mean this, all the 4 byte will be combined to a single byte, single cell, which is of type V, which is a floating point. So and arithmetic will be done of 4 byte, it is 2 byte, you already know that, and the character is 1 byte only. So it will just one cell is one character type. So in this way memory is being allocated to different variable according to the data type it is being using. Okay, hope this is clear to you guys. Now let me show you the point. So now let me show you the point here. What does this point A, what I have explained there, is more cleared by this point. What I explained there. So a typical machine has an array of consequently number or address memory cell, which I have told you that consequently it will be had some memory cell type structure which I have shown, and that may be manipulated individually. So which I have seen that. So earlier example that this was the addressing mode, and this is 2 bytes for integer and 1 byte for char. So in this way we are manipulating in according to data type provided in the code. We are providing in the code. Operating system allocate the space according to the data type provided by us in the code. Okay. So one common situation is that any byte can be a char. Okay, so any byte can be char. A pair of 1 byte cell can be treated as short integer. Okay, which I have shown. 4 adjacent byte from a long, and which type is just data type. Okay, data type, types of data type, different data type. A pointer is group of cell, often 2 or 4, that can hold an address. So pointer will be group of cell, means actually it I have already shown you that if your architecture is dependent on 32-bit architecture, pointer will, suppose this is the memory address, and these 2 bytes will consider that and will be allocated for pointer variable, no matter whatever you declare here. So don't think that if you declare float here, to p variable will take float here. No, it's a pointer variable. I already told you this is pointer variable. It will treat, it is different than normal variable. It's not the data type of this pointer. Pointer data type is defined by the architecture itself. Okay, so this at this point it must be clear to you guys. I have repeated so many times this thing. So it will not have divide 4 byte. It will always contain the 2 byte according to architecture, 2 byte or 4 byte. Okay, it will have the architecture for 2 bytes only. Don't think that if you use char here then it will cover 1 byte p variable. You have this 1 byte. No, it's not possible. Okay, so it depends on only the architecture which the written in this point. Okay, so this point very crucial. In one paragraph you can see so many things can be derived from one statement or from this point only. So very important point. Okay, try to just I have taken this statement from Dennis Ritchie book. So this is very confined book. I already told you that I am following this book from the first lecture onward. So this is very classical sentence. Okay, now moving on, let me just show you. So this is the memory address which I have declared here. So I just forget that I have just already have designed this for my program. So I just design, I don't have to write this. So if the float, so suppose in the same thing, a float B and int A, and so tell me guys, I have written this point. Okay, and int variable asterisk pointer ptr. Okay, or float variable, let me write it here. Suppose floating point pointer, it's fptr. Suppose, tell me guys, the referencing, pause the video for a moment and tell me that how this will be allocated in this memory space. Okay, so hope you think about this guys. So let me just do it for you if you haven't understand it. So 4 bytes, so this 4, suppose this 4 combined will be floating point. Okay, so it will be floating point number B, and for a variable, suppose a will have 2 bytes here at 16 bit, 8 bit. Okay, it's architecture 8 bit. Okay, remember this point. Okay, before solving this question. Okay, and so A will we have this value. So this is A and this is B. So what IPTR and FPTR? These does they store the same value or different value? That's the tricks come here. Well, you might have done these things easily, but and if you guys have listened to me earlier, that is both the pointer will cover 2 bytes only, depending on architecture. Suppose my architecture support 2 byte pointer, so it does not depend on the pointer variable. It is being pointed. It's just depend on architecture. This is the basic difference between pointer variable and normal variable. Okay, try to understand this point, guys. So this is PTR value, and again 2 bytes FPTR value. Okay, see this. Both are pointer variable of integer and floating point respectively, but they both cover the 2 bytes because pointer variable depend on architecture. So now from this point, it must be clear to you guys. Okay, so hope this is clear to you guys. Okay, if you have any doubt, please post in comment section. I will reply them. So now let's now move on. So now consider this declaration. Okay, so hope you understand. If you have understand from in the last slides, you can do it easily. So pause the moment for a guys and just read its points. Okay, now what will it doing? First line say that integer x have been defined, have been declared and assigned a value of 1 and 2 similarly, and z is a integer array of 10 elements. Okay, so how this will affect? So x will be have some memory space similarly, and ip is a pointer which is been declared. Ip is pointer with integer type, is being pointing to an integer value. So now it is not specify which value it will point. It's either x or y, because or z both are pointer variable. So we have to declare use the ampersand sign. So you have to use the ampersand sign to get the address of this variable. So x is being declared at 2 and y and 10 variable of z. So IP will have the it's a pointer variable. If you remember the asterisk. So what IP is a pointer, so it will contain the address. Using x you can access the address of any variable we have seen earlier. So x, so what will now happen? IP will point to x. Okay, and now the z variable is declared. Okay, I have to show, I should have shown this, but because of space I have to show here. Okay, so this will be address because integer type to 2 byte will be covered. So addressing will be this type. I hope you remember this from array lecture. Okay, this point must be clear to you guys. Okay, so this is z variable, and x has value 2 bytes because it is integer, so it will cover the 2 bytes here, and similarly y will cover 2 bytes and with a value of y equal to 2. So now what is happening here? Now let me just get into this point. What is happening here? Y equal to IP. Y equal to IP means y variable is being an IP. I already told you that if we use without the declaration of pointer, I would asterisk somewhere, without a declaration of pointer, it will just assess the value of this variable p. So it will assess the variable IP. So IP is what? IP contain the address of x variable. Means if this is x and this is IP, so IP is pointing to variable x. Okay, so x which have address, suppose it's a 100, so it will store 100, and x a variable 1. So you can see it from here also. X is pointing to y here. So if we write y equal to value at IP is value at IP. So IP have what's this mean? It will do double layer of calculation. IP value at IP contain the address of x. You remember this point. So this will do cancel out and just give the value of x. Means give the value of x. What's it officially means? The give the value of x. Give the value of this address of x variable. Okay, so it will give the x variable of what? X have number 1. So y will become now 1. Okay, so it will store 1 here, and now IP is value of IP is becoming 0. Means IP has value of IP, means IP value at IP means value of IP. Here value of IP means what? Here already know as value at address of x. So address of x, suppose at x is at 100, so 100 and it's 102 something. So value at 100. So 100 have what? Value of, so value IP. Now this is the in the left hand side of this equal to. So IP will, this mean that value of IP make it to 0. Okay, so it will now become 0. Why? Because IP is pointing to X here. So if we make a value at IP, mean value of 100 at 0, it can be done in two ways. You know, guys, the similar way is just make an X as 0, and one point we learn from pointers that we can also use the variable as a mnemonic to the pointer, so it will just show the value of X also. So this two means same. Okay, I will show you using code also. Okay, hope you are not if you don't getting it. And now IP is being pointed to, now in the last line you can see IP is pointing to address of first address of Z. So this is used to pointer to an array. And I will also show you the relationship between pointers and array in other lectures also. So IP will point to now Z, variable Z here. Okay, so this will now point to this array. So hope in this way it is clear. So I will show you another lecture. If you write just A at Z, it will also make the initialize reference to same variable. Okay, I will show you in other lecture. This is the relationship between, this give the relationship between arrays and pointers. Okay, arrays and pointers is most important topic in this arrays and pointers topic. So arrays and pointer I will show you in another lecture. Okay, so now hope this is clear to you guys. Hope this this mathematical expression is clear to you. If it is not clear to you, I will show you in the next lecture in coding example. Okay, remember these things. Okay, I will just code it out, guys. Okay, so it will be more clear to you here. If you're not understanding from a theoretical perspective, you will definitely understand from practical example. Okay, so now moving on. So last points. Okay, the declaration of a pointer p is indeed a mnemonic. I have told you just a mnemonic. It said expression IP is an integer, so means IP is pointing to a integer variable. Okay, the syntax of declaration of this point is clear. I have already explained it here. Okay, so I didn't explain it more detail. Okay, the syntax of a declaration of a variable mimic the syntax of expression in the which variable might appear. So, okay, so syntax of a declaration for a variable mimics the syntax of expression in which the variable might appear. Okay, so it will be more clear at this point. Leave it this point, guys. Okay, it will be more clear when I will discuss in the next lecture will be about pointers arithmetics. Okay, arithmetics where this point will be clear to you. Okay, so now moving on, let me just show you the other points here. So you should also note that the implication that a pointer is constrained to point to a particular point kind of object. Every point to a specific data type. There is one expression pointed to void. Okay, so the last before this line. Okay, so this line must be clear to you now. That you should know implication the pointer is considered to be point to a particular kind of object. So everything is written in object nowadays. In you can say the naive way that everything in code is as an object. Okay, so every pointer point to the specific data type. So it will depend on the specification we have provided. So you already know that if int, so it will point to an integer variable. If you use float here, it will point to floating point variable. Okay, so in this way. So first line must be clear. The last paragraph is using brackets, using the parenthesis. Is there is one expression a pointer to a void is usually hold any type of pointer. So remember this. This is very important point. Crucial point. Don't use ampersand here. You will substitute pointers. So if you write void here, okay, if you write void here, so what will happen? Now this will have to any type of data, any type of pointer. It can be integer, it can be floating point, it can be anything. If you write void here, okay, this is the meaning of last statement, and it cannot be dereferenced by, means you have to specify the address also, and means integer variable a here, and if you just point a equal to a, so it will now p equal to a, so it will store the value, but it is a void type, so it cannot be cannot be dereferenced by itself. Okay, so hope this because using void is does not specifying what type of data type you are using, so it will work according to the system, and it may give the garbage values sometime. Okay, so this point will be more clear in the upcoming lecture where I will discuss it. Okay, so now moving on. So that's all for today, guys. So hope you have some idea about the formal definition of pointers. It might be too much for you guys in to learn in one go. So just watch one or two more time, and you will definitely understand what you have studied here. And if you haven't understand yet, you will in the next lecture. I will just not. I will not go into. I have told you that I will go into the pointer arithmetic. No, I will just show you. No, I will not do that. I will just show you the codes. Okay, so by coding you will understand it more. Okay, so that's all for today, guys. Thanks for watching. See you soon.